Let's start out with an example here. This problem is similar to an Underwood-Dudley number theory problem, except it's slightly different, and hope you enjoy it. Let's just try to first determine various numbers that are members of this set S. We'll start with n equals 10. Now, I'm going to go ahead and declare that 10 is a member of S. And notice that 10 is 2 times 5, so that is the least prime divisor of 10, since 10 is 2 times 5. Okay, now, and this is true since 2 to the 4th is greater than 10. Or, yes, 2 to the 4th is greater than 10. And notice that this statement right here is the membership condition. P is greater than the 4th root of n. It's more convenient to write this as p to the 4th. These are both positive numbers, so you can square both sides and maintain the order of the greater than symbol. So this is, and this is clearly easier to think about, right? P to the 4th is greater than n, just raising both sides to the 4th power. And so we get 2 to the 4th is greater than 10, which means 10 is a member of our set S. Now, it's in a similar fashion if you do n equals to 10, or excuse me, let's do 24. Let's do 24 here. Keep them small. Now, this is equal to t cubed, 2 cubed, times 3. So notice that 2 is not greater. 2 to the 4th power is not greater than 24. Right? And again, we're using this formulation. It's easier than trying to think of this one. This is much easier to work with this than this. This is just the way it was stated in the number theory textbook. Okay? So what we have right here is this 24, let me just write it down here. 24 is not a member of S. So the smaller numbers are fairly easy to deal with. You just have to establish the smallest prime factor. And I just did easy ones where 2 was clearly the smallest prime factor, the least prime factor. Now we have a question with a much larger number. The question is this 15-digit number a member of S? Now you can see quickly that this is not divisible by 2 or 5, okay? And also by the sum of the digits test for 3, it's not divisible by 3. There's a test for 7, okay? And I'm not going to go through it. I'm just going to jump to the solution here more or less. And there's the divisibility test for 11. And it's based on the fact that 10 is congruent to -1 mod 11. Right? And so what that means is 10 to the n, where n is a positive integer, is greater than -1 to the n. And of course, it's assumed mod 11 at this point. Now, there is a divisibility test for 7. It's not hard. You take double this, subtract it, and keep going and see if it's divisible by 7. But I'm just going to not do that. We'll just jump straight to 11. Okay. Now, you see, here's where you get this alternating business. This right here, this 1 right here is associated with 10 to the 4th. Let me make that as small as possible to make this readable later on. Right? This is 1 times 10 to the 4th right here. This is the 10 cubed position, 10 squared, and 10th position. And so what we can do here is notice that this, when it's an even power, 10 is congruent to 1. 10 is congruent to this number mod 11. So the mod 11s just go away. I mean, excuse me, I didn't say that right. The powers of 10 just go away because they are multiples of 11, or you can replace them by 1 is what I'm trying to tell you. You can replace them by 1 or -1. So for 10 to the 4th, you can just replace 10 modulo 11 with 1. And so what you end up with right here, I hope that helped, 1, okay? And now when you get to 10 cubed, this will be a minus. So you're replacing 10 cubed with minus 1. So you you do a minus 3 here, okay? And so on and so forth, folks. So you're alternating because of this statement right here, mod 11. Okay, so you get 6, now minus again, and then plus 3, right? Okay, so you see all the work is really done at this stage. Once we know the prime factorization, we're virtually done with the problem. So the time is being consumed right now. So what is all this equal to? 1 minus 3 is negative 2. Plus 6 is 4, minus 7 is negative 3. So you see this is 0. And notice that this is a multiple of 11. 0 is a multiple of every number, okay? 0, I mean, 11 times 0 is 0. 9 times 0 is 0, right? So 0 is divisible by anything, right? Not the other way around. You can't divide 0 in anything, but you'll learn in a number theory course that they're really teaching the way they should. 0 is divisible by anything but 0. That's why a lot of stuff actually works in number theory, okay? So what we know right now is that 11 divides our big 5-digit number. It's a divisor. This vertical bar, if you guys haven't seen it, it just means divides. Okay, so 11 divides 13,673. Now, y'all, what I'm going to go ahead and write down is we know 11 divides it, and it turns out that 13,673 11 divides it twice, actually. So it's equal to 11 squared, which is known to be 121. And then we get this number 113. And again, that's some work you would have to do without a calculator if this was, say, a competition problem. All right? So you see there, and it's very easy to believe that this is the prime factorization because it doesn't really matter that 113 is prime as far as the way this problem is going to work out, you know. But you see here we have 11 squared times 113. The last digit is 3 here. Very believable, right? Now notice that 113 is less than 11 squared, right? Okay, so you can see right here, if you just take a look at this piece right here, we'll write down 11 to the 4th. This is just what we were using upstairs a while ago. Okay, we have 11 to the 4th, okay, is greater than 11 squared. This is 13,673 right here, and here's your prime factorization. That is greater than 11 squared times 113. Since 113 is less than 11 squared, and you see 11 squared and 11 squared would give you 11 to the 4th here. And this is still, 11 to the 4th is not greater than 11 to the 4th. It's equal to it. But since this is less than 11 squared, it's clear that this is true, okay? So, and again, this is our number. This is our number we were interested in, 13,673. So, y'all, the answer is yes, 13,673 is a member of our set. Okay, that completes the problem. Now, again, this is a standard. I won't call it standard, but this is an example of where finding the prime factorization is everything. You see, we went through all this, and I didn't even show you the divisibility test for 7. It's clear it's not divisible by 2, 3, or 5. 7, I didn't show you. I showed you why it was divisible by 11. Okay, and then I still left out the work involved dividing 121 into this to get 113. Okay. But once we're there, you're essentially done with the problem in 10 seconds, notwithstanding how slow I write. Okay, so 13673 is a member of the set S. So anyway, I kind of like it. I composed that problem. There's probably problems with it, but I kind of like the idea of this set builder notation and asking yes/no questions that require a certain amount of computation and understanding. Let me know what you thought. Thanks for viewing.